last time we talked about if lines are parallel, then we have all of these theorems that we can use, but we have to know our lines are parallel first. So these are all called theorems, and then you have one postulate, which I said if you call it a theorem, that's fine. Now, what's going to happen today is if you flip to the back of your vocab packet, you're going to find this constructing parallel lines. We are actually going to make parallel lines. Instead of me giving them to you today, we're going to prove that they're parallel. So we're going to be doing the converse today, which is going to feel like opposite day. So it's going to feel like the opposite of what we did last time. So in order to kind of start you off, I'm going to show you one way to make parallel lines, which is probably the most favored way to do it, and that is this double perpendicular idea. So go ahead and take your compass. You're going to need your compass and a straight edge. And we are going to make two lines that are perpendicular to the same transversal. And this is going to end up making parallel. Okay? So think back to when we did constructions and how we made a perpendicular line from a point not on the line. So smiley dimple X might come to mind, right? So you're going to put your compass on P, and you're going to make a smiley face that intersects the line in two spots. And again, you're going to get these two dimples right here, two intersections. And then from there, you're going to make an X, which is part of the smiley dimple X. Then you are going to connect your X to your P. And that is going to create a perpendicular from a point not on a line to a line. Now, what I'd like you to do is I would like you to take and make your line that you just made, let's make it an actual longer segment here. Let's go up through P and make it longer than we normally do, because this right here is going to end up being the transversal for us. Oops, transversal. So that will be our transversal. Now, in order to make parallel lines, we're going to make another line perpendicular to that transversal. So we're going to do everything we just did, but we're going to do it from P. So this is where it gets a little tricky because you're going to be doing it sideways. You're going to do another smiley dimple X, but you're going to start at P, and you're going to make your smiley to your transversal. So you're going to make a semicircle either to the right or to the left, and it's got to intersect that transversal in two spots. So it's going to hit like here, and it's going to hit like here. Now, you could do your semicircle to the left if you wanted. I just did it to the right, but it doesn't matter. Now you got to open your compass further, stretch it out, and the further you open it, the better it's going to be. You are going to use those dimples or those intersections to make another X over here like you did just a second ago. So now I've done a smiley X to my transversal. Now when I go to connect that, I'm going to use a different color here. If I connect these two, then what I get is, well, I don't know, you tell me. I've done a double perpendicular, and now if you look at this purple line compared to the original black line, you'll probably notice that they're parallel. And that's because anytime you have two lines that are both perpendicular to the same transversal, they're going to be parallel. So that's one way, if anyone ever asks you to construct parallel lines, that's probably my favorite way to make parallel lines, because it uses a construction that's pretty easy for you. There are other ways in the book, but this is the only way I'm going to show you this year because we're kind of short on time. So down here it says, what do you notice about the two lines? The two lines now, they are parallel. And remember, the parallel is the 11. And the two lines I'm talking about are the new line that I just made and the original line that I started with. Okay, now the reason why that construction works and makes parallel lines is because of something called the perpendicular transversal converse. So I'm going to show you what this is, and you'll be filling it in eventually on your other part of the vocab. But in a plane, if two lines are perpendicular to the same line, then the lines will be parallel. So notice that I have two lines that are both perpendicular to the transversal, which is causing the lines to be parallel. It's just a cool way to see that converse like in action, how it actually works. So we won't really be using this much. It might pop up in one proof or something. We don't use it all that often, but that is one of your converses. And today I told you we're focusing on converses. Okay, so we're going to come back to that kind of idea of making lines parallel in a second. We're going to look at something in 3-6 that is a concept that I want you to know also, and then we'll go back to the idea of being converses. All right, so this one is a application of finding the shortest distance somewhere. So I don't know if you guys know, but when you guys want to get somewhere, the shortest distance is always going to be a distance that makes a 90-degree angle. So if I could get to Indianapolis from Carmel by just going straight down Meridian, if there wasn't as much traffic, I could get there in the shortest route, right? Rather than taking 465 if you've been on the interstate and going around the city, that's a longer distance. Now sometimes it's shorter because of the traffic, but the shortest distance is always going to be a perpendicular distance, and I'm going to prove that to you right now. So what I'd like you to do is I would like you to make a perpendicular from R to the line. Well, you should know how to do that because we just practiced when we made parallel lines. So you're going to do your smiley dimple X. And then we're going to connect the X to the R. And I'm going to put a right angle box there because I want to emphasize that these are perpendicular. So that intersection, it says, is going to be M. So go ahead and label this as M. Now what it wants you to do is it wants you to label 3 random points on the line. You can put these 3 points anywhere you choose. I need you to place A, B, and C anywhere on the line. So anywhere that you want. Now we're going to connect and make those segments. So I want you to make segment AR, segment BR, and segment CR. Now, if you have your ruler, you can use your ruler, but your compass is kind of fun to measure with because it's different. So I would like you to look at all 4 of the segments that I have there, and I want you to use your compass to find the shortest one. So this is kind of a fun application. So if I look at AR, that's how long AR is. If I look at BR, this is how long BR is. So I'm going to go along and figure out who the shortest is. And if you look, you probably can tell just by looking. But nothing is shorter than the segment that is perpendicular. So if I'm driving to Indianapolis, that distance is always the shortest if I go down Meridian or Keystone because it's straight down to Indianapolis versus trying to go diagonally to the line. So it says which distance is the shortest. For everyone, no matter where you put A, B, and C, segment RM is the shortest, but I won't put the little segment bar because it says which distance, and remember distance is just the 2 letters. So RM is the shortest distance of all of them. Okay, so we're going to flip that over to the back, and we are going to apply that idea. We're going to skip A because you're going to try A in a second, and we're going to apply that idea to B, all right? B is the harder one. So it says apply the construction to construct the segment that represents the distance, which means shortest distance, from M to AR. Okay, so here's M, and we need to go down to AR. So we're going to do the construction, and so here's what kids normally do. They start by putting their compass here, which is what you're supposed to, and they make a smiley face, and then they look at me with this funny look like, wait a second, that didn't work because I don't have 2 intersections. So remember the idea is you can always extend these segments. It doesn't have to be a segment. So you are going to do a smiley face. You're just going to need to make that segment longer so that you actually get 2 intersections. So go ahead and extend the segment, and then you're going to do your smiley from M, and you're going to make your X, and then you're going to connect. Now when you get done, if you have a highlighter, or you can just circle this right here is called the distance. So I want to tell you that a lot of times math books won't say the shortest distance, it just says the distance. So for instance, my distance to Indianapolis is the shortest distance. They're not going to come out and say that every time. So this would be the distance, or the shortest distance, from point M to this segment, which you have to extend. Okay, so now what I want you to do is I want you to try part A, read which distance it's looking for, and then create that perpendicular distance. which would be the shortest distance.